Okay, good day everyone. So I'm about to present Pareto pairwise in the design project. So let's take a look at example number one. So we have here um, design alternatives. So consider that we have four options, or we have four alternatives, design alternatives. Then that design alternatives are subjected to each performance criteria. Okay, so this would be the performance criteria, or the criteria number one, criteria number two, and three. So we have cost of education, number of ABET accredited programs, and effectiveness of career support, in which four is the best and one is the worst. No, so let's say, for instance, we use pairwise comparison. Okay, for this method, let's say for instance, comparing design alternatives 4 to 3. Okay, then comparing 4 to 2, then comparing 4 to 1. Okay, so let's proceed with the first procedure, which is comparing 4 and 3. So as you can see, okay, this is actually highlighted. So we use a pairwise comparison for that. So cost of education, when it comes to the cost of education, the less is better. So when it comes to that design alternative, so offer 350,000. Okay, so for this performance criteria, option 4 1 compared to option 3, because cost of education is lesser compared to option 3. Okay, when it comes to the number of ABET accredited programs, okay, the higher accredited programs, ABET accredited programs is better. So for this example, option 4 again, okay, is better compared to option 3. Okay, so when it comes to the effectiveness or career support, 4 is better. Okay, option 4 is better compared to option 3. Okay, so on this particular comparison, comparing design alternatives 4 and 3, okay, all performance criteria dominated by option 4, no, compared to 3. Okay, so it means to say in all criteria, design for 1. Okay, so again, so skipping that, okay, this would not be this would be eliminated for our comparison, since the same alternatives for 1. Okay, so we compare 4 and 2 for the next procedure. So this one, 4 and 2. So when it comes to the cost of education, again, option 4, design alternative 4, is better. When it comes to the number of accredited programs, design alternatives 4 is better. And effectiveness of career support, design alternatives 4 is better. Okay, so again, okay, design alternatives 4 dominates design alternative 2. Okay, in all criterion. Okay, so the next procedure would be comparing option 4 and 1. Okay, the remaining alternatives. No, okay, so in this design alternatives, option 4 is better when it comes to the cost of education. Again, for the number of ABET accredited programs, option 4 is better again. Then effectiveness of career support, option 4 is better again. It means to say that option 4 in all design alternatives is better, and one for different criterions. So after three pairwise comparison, okay, so we conclude that option 4 dominates all other options, design alternatives, and it is actually the best than the other options based on each of these three criteria. But in the design project, okay, well, it's Pareto, so it means to say, okay, um, it doesn't dominate all other alternatives, so that option 4 will not be considered, okay, in our design project. Okay, because there's no such design that dominates all criterions. Okay. Today for the example number 2, so we have for design alternatives, then the performance criterion would be the cost of cell phone camera image sharpness. 4 is the best, then 1 is the worst. Then ergonomics, 4 is the best, then 1 is for the worst. No? So consider that we have for design alternatives. This would be the cost of cell phone for each design alternatives. This would be the value for the camera image sharpness, which is 4 is the best, and ergonomics 4 is the best. Okay, so comparing options 4 to 3. Okay, so if we compare the options 4 to 3, when it comes to the cost of cell phone, okay, design 4 is better. When it comes to the camera image, design 3 is better. When it comes to ergonomics, design 4 is better. So neither one dominates the other for this comparison. Okay, so for comparing 4 and 2, option 4 and 2. Okay, so for option 4 and 2, okay, so when it comes to the cost of cell phone, option 4 is better. When it comes to the camera image, option 2 is better. When it comes to ergonomics, option 4 is better. So the comparison of option 4 and 2, okay, neither one dominates the other. Okay, how about comparing option 4 to option 1? Okay, for the cost of cell phone, 4 is better. When it comes to the camera image, one design 1 is better. When it comes to ergonomics, okay, option 4 is better. So comparing option 4 and 1, neither dominates the other. Okay, so comparing about again 3 to 2. Okay, so cost of cell phone is option 3 is better. When it comes to the camera image, option 3 is better again. When it comes to the ergonomics, option 3 is better again. For this design alternatives to, okay, this would be eliminated, no, for our Pareto optimal. Okay, because all of the criteria mentioned was actually dominated by option 3. Okay, comparing 3 to 2. How about comparing option 3 to 1? Okay, so when it comes to the cost of cell point, okay, option 3 is better. When it comes to the camera image, option 3 is better. The ergonomics, option 3 is better. So again, option 3 dominates option 1 in all the criteria performance mentioned. So this would be eliminated. This would not be considered as a Pareto optimal. So the remaining would be, we are left with options 3 and 4. If we are trying to compare it again, okay, this one for the cost of cell phone, okay, alternative 4 is better. When it comes to the camera image, alternative 3 is better. When it comes to ergonomics, okay, option 4 is better. So this would be considered as a Pareto optimal, the options 3 and 4. Okay? Okay, for example number 3, we have again, if we consider for alternatives, then the whatever the performance criterion it is, okay, so comparing 4 to 3, okay, again, let's do the pairwise comparison. 4 to 3, so 4 is better. Okay, the option 4 is better. Okay, when it comes to the performance criteria 2, option 3 is better. When it comes to performance criteria 3, option 4 is better. So neither dominates the other. Okay, again, comparing 4 and 2. Okay, performance criteria 1, 4 is better. When it comes to performance criteria 2, okay, design 2 is better. Performance criteria 3, design 4 is better. So neither dominates the other. So comparing option 4 and 1. Okay. one is option 4 is better, then option 4 is better in performance criterion 2, and option 1 is better in performance criterion 3. So it means to say comparing 4 to 1, okay, when it comes comparing option 4, okay, here to 1, okay, in all criteria, okay, 1 is highest, okay, compared to zero point 0.8, then option 4 is better. When it comes to performance criterion 2, option 4 is better because option 1 is 0. When it comes to the performance criterion 3, option 4 is better. So the sign 1 was actually dominated by option 4. So option 4 dominates option 1. So this would be eliminated and would not be considered as a Pareto set. Okay, so how about comparing option 3 and 2? Okay, comparing option 3 and 2 performance criterion 1, option 3 is better. Performance criterion 2, option 3 is better. Performance criterion 3, option 2 is better. So neither dominates the other. Okay, so no need to compare 3 to 1 because 1 is already eliminated. Okay, so the remaining would be option 2. Okay, uh, 2, 3, and 4 are said to be Pareto optimal or Pareto set. Okay, how about for example number 4? So we have, if we compare each of these design alternatives 4 and 3, okay, when it comes to each criterion, okay, it would result that any of the design alternatives neither dominates the other. Okay, it means to say there's no uh, design alternatives that dominates other design alternatives. Okay, it neither one dominates the other. Okay, so this would be considered as a Pareto set, all of the design options. Okay, when it comes to the linearization, okay, so we have a formula here, okay, because in our design there are different measurement we used to identify each criterion. Let's say for instance for design, for the example number 1, we have here cost of education, it's pesos. This one is units, and others are for in the scale of 4 to 1. Okay, 4 is the best and 1 is the worst. Then to linearize it, okay, to have a common number for each of the criteria, which would be considered later on. Okay, so we have here to convert that into numbers. Okay, okay, 1 to 10, as 10 being the highest, no? So we use this linearization. Okay, so we have, if the first equation is this, okay, if our first performance criteria, we normalize that, this would be the equation for when the best is smaller value. Let's say for instance, the the best the smaller value for cost of education. When it comes to the cost of education, the smaller value is the best, so we will be using this equation. Okay, when we use this, when the higher value is better, so we use this equation. let's say for instance the number of accredited programs. The higher the better, so this would be the equations for that now. Okay, let's say let's have an example. Okay, which is for example number one. Given an example number one, of course 4 is not included anymore because it dominates all the other options. It means to say that in all performance criteria mentioned, okay, option for one, okay, so this would be included, not included anymore. So the alternative design 3, 2, and 1 would be considered as Pareto set. So that would be considered for our linearization. Okay. So as we go on to our linearization, okay, for the cost of educations, the equations used is that when the best is a smaller value, so we use this equation. So you can see it's already uh, tabulated in Excel. Okay, so 9. Okay, the maximum in the row. Okay, here. Okay, in that row, this means to stay. Okay, then minus the performance criteria for that row, which is this one. Okay, this is the performance criteria for that row that we're trying to get the values for linearization. Okay, then over, okay, the equation is max. Again, we use that to highlight this one. Okay, for D107 to 109. Okay, just follow the formula. Okay, then minus the minimum in the row will be selected by the Excel. Okay, 100 for the cell 107 to 109. Then plus 1. Okay, so this would be the result. Okay. Okay, then just need to copy that. Okay, in the Excel. Control C, then Control V for the next now. And Control Shift and Control V for the next. Okay. So for the number of accredited programs, for the equations used for that is this one. Okay, when the best is higher value. Okay, again, the use of these equations are uh, through Excel functions. I just need follow the formula. Okay, and so on and so forth. Okay, so that's it for linearization. So the linearized value for our example number one is that this one. So we consider here, okay, for option 1, 2, and 3, this is the linearized value. Okay, so looking at the options now, who got the 10 scale, okay, this is better, and this is better. Okay, for our example number 2, okay, for again cost of self one, we'll use the equations this one when the smaller value is the least cost. Okay, the camera image, okay, the higher value is the best, this one. Again, for the ergonomics is this one. Okay, the same with example number 3, and so on and so forth. Okay, how about for the those criterions that we should need to give weights? Okay, remember that we have let's say for example number 1, this is our performance criteria, and this one would be the level of importance, or the criterion's importance, which is we rank it 1 to 10, or 0 to 10 rather. Okay, then we have the weights would be automatically computed based on the level of criterion you set. Okay, then your design options, design 1, design 2, and design 3. Okay, so let's say for instance, okay, for the ergonomics, okay, on the perspective of the client, okay, they would consider that uh, in their the importance of this criterion, they set it 10, and the number of ABET accredited programs, they set it 10. Then the effectiveness of career support, they set it 10. Okay, so all in all it's a 30. Then of course the weights would be automatically be given based on this the average of this. Okay, just need to divide the that criterion to each, to the summations of that. Okay, so you can get automatically the weights. Okay, so let's means to say for the design one, okay, you will be applying 33%, okay, for that weights. Okay, and 33% for the results for design 2, and the result for design 3 is also you multiplied it with 33%. Then the results would be like this in percentage. Okay, and this one. And after getting the percentage, you can actually compute the, for each designs, okay, the percentage of each design per criterion. You add it up, okay, this would be the percentage per design. Okay, example, if you have, okay, let's say for instance, if you have performance criteria or decision criteria rather, you have economic, safety and health, and environmental. Okay, then the level of importance or criterion importance range to 0 to 10. Okay, this is actually answerable by the client. Okay, so 10, okay, then 9 and 8, so it would be automatically it would give weights automatically based on the level of criterion set by the client. Okay, or the perspective of the client. Okay, then we have three design options. Okay, let's say for instance this is the linearized value already. Then if this is the linearized value already, we get it from, okay, from the conversions to the raw values to the linearized value. Okay, then how we are going to apply these weights? Now you just need to multiply it. So you have 37% and so on and so forth. Then for this design one, okay, let's say for instance 100%. For this design two, this would be considered 96% total. Then for the design three, 67% total.